So good morning, everybody. Yesterday, I got pulled into the session. I was not supposed to attend. Hari was not well, so I had to double up for that. So I'm slightly more prepared for this session than what happened yesterday. So I think SDV managed to set up our expectation. There's a lot of optimism in terms of where SDV took us. Faster time to market, continuous innovation, great improved life cycle management, cost reduction and lightweighting because of the architecture also. And of course, the great hope and sort of future of additional revenues through the digital streams. I think everything was right. Everything is right still in terms of what SDV means to all of us. What has really then happened? Why? There is definitely a sort of a stormy situation right now in terms of SDV not delivering up to his expectation. And you can see more than 40% of recalls are software. Actually, a lot of no-fault found situations are also software. So it's even a bigger warranty issue now, up to $1 billion to $4 billion of warranty claims are largely software-oriented and no-fault found-oriented claims also. So everything is about software. OEMs have spent, more than half the vehicle launches have been delayed. Even though you will see launches happening, it's a lot of compromise in terms of what these launches were supposed to happen. And this is not a good situation for the industry. Most of the things that we wanted to do in the last 2 to 3 years have not really happened in the pace that we wanted it to happen. And let me come back to, again, yesterday I talked about 3, but I think today I will talk about 2 important aspects of it. And I think let me spend more time on the architectural aspect of it. The first big problem is architecture. And I think it's very difficult to understand what architecture means. It is not a piece of paper. It is not a drawings on the PowerPoint. It's not Visio drawings or anything. When you look at architecture of anything, it is about you understanding certain set of requirements, not all. And that basically drives you to certain choices that you have to realize those requirements. The choice that you make comes with some benefits, which you want to achieve because you want to address the requirements, and it comes with some constraints. So every choice is a constraint along with it, tagged along. Now, architecture, when you say somebody actually finalizes an architecture, and architecture is a combination in our world of the system architecture, what SoC, what network, what hardware. It's about the software architecture, service-oriented, not service-oriented, C++, C, Rust. It's about how the architecture controls the mechanical device, the mechatronics part of it. So it's all integrated together. So when you look at architecture and the constraints of the architecture, because of a choice made about the architecture, when you understand all the constraints that you pick up with the choice, it is a great situation because you can mitigate the constraints, you can design for the constraints. Everything, entire process can actually look at how to overcome that particular constraint. A lot of times when you deal with new technology, you're not aware of the constraints because of technology being new, skills not being trained. So I think most of these constraints at the beginning of SDV journey were not known. And when the choices were made, I have visibility into 9 different architectures worldwide now. And I have visibility into generation 1 and generation 2 of those architectures. And when I look at these 17, 18 concepts together, they are essentially different completely. It's interesting, right? The first slide is more or less the slide for all the OEMs. Everybody wants to achieve exactly the same thing. And I don't think a button here and there, a color on the display, a screen here and there really matters in terms of architecture, right? But yet, There are so many different challenges that we're dealing with as an industry. Why? Because our architectural choices are different. And because our choices are different, we are dealing with different constraints in an industry where the knowledge about those constraints is not proliferated. Like from a single ECU perspective, everybody in this room, probably 80% of the people would know what the problems are, right? We know what the challenges are. We know how to execute the process of bringing a single microcontroller-based ECU in. But do you remember the time when a single microcontroller ECU got sort of expanded to 2 cores or 3 cores and how we struggled with that? Many of you would have experienced that struggle. Just single core to 2 core in a single microcontroller, yesterday, as I said, shifted the problem into asynchronous domain. 2 cores were not synchronized with each other in terms of software execution. And then we started getting challenges. And we had to fix those challenges. And we learned in the process. In last maybe 5 or 6 years, we've learned about multi-core and all the challenges that are there. So I think when you're shifting to something called as central architecture, Ethernet, etc., we have many, many challenges. So I think I jumped into this slide. So we have challenges on the system. You have a system from a point of view of heterogeneous network. We have now new technologies coming in. And new technologies is not just the topology. It's not about Ethernet. Ethernet at 100 Mbps, 10 Mbps, 100 Mbps, 1 gigabyte, and 10 gigabyte are all different. They have different challenges. 10 gigabyte will cause a problem in the zonal on the EMI/MC side. 1 gigabyte and 10 Mbps together through a switch, you'll have to decide what your switch configurations are and what to drop and what to prioritize. So new things coming out from a network perspective. You have significant wake-up and power constraints. You want Linux, you want QNX on the HPC side, you want microcontroller operating systems on the microcontroller sides. What is your startup sequence? How do you want things to start from a safety perspective? Is your architecture considering those things in the platform side? Is your platform capable of ignoring everything and be up and running in the safety constraints that you have? I think those are the challenges. We also have complex communication now. You want to retain some legacy through CAN. You may have LIN, and then you have suddenly Ethernet coming in. What kind of strategy do you want to adopt in terms of connecting these networks together? Choice. Software architecture. When you look at HCP, what is your consolidation strategy? Application consolidation. Which applications that currently happen in the microcontroller domain do you want to shift to the application processor domain? Application processor as a processor and microcontroller as a processor are different. Their memory, their processing power, their context switching overheads are completely different. Does the application that you put in actually comply to these things? Is it really independent? Can you actually not think about those issues and move the applications around? I don't think so. So I think that's a complication. Diverse technologies, right? You want C++ in the application processor domain. You still want to continue with model-based system engineering. We want to sometimes look at MCAL as device drivers here, and then BSPs there, and then there is Android on top of it somewhere. So I think there are many such diverse technology challenges. What do you do with legacy software? 80%, 70%, 60%, 50% may be there. It may be with suppliers. Suppliers may not be able to share certain things and share only few things. Do you know what exactly you want to take up from the supplier before you actually take it up? Do you have an understanding of how to deal with it when half the things are not there in terms of documentation, right? Because sometimes a lot of work happens because of tacit knowledge. Of course, safety documentation exists, but most of the knowledge documents don't exist in organization. These are tacit knowledge bits. And you cannot just move tacit knowledge from one organization to another organization. So there is this software architecture challenge resulting into choices. And then there is a software and system harmonization issues, right? Compute and communication optimization, timing and latencies, decisions and optimization, and not to ignore the last but not the least is the safety and security aspects. Now, There are hundreds of issues on this, hundreds of this. And each issue can result into your architecture being a choice that you make where you suppress out of the 100, maybe 10 issues, and you create, you retain the 90 issues, and you create another 10 or 15 additional issues because of the choice that you've made. So, what is the answer on that? I think the answer is the process. And I think this is the most important aspect that has been completely ignored. And if you look at most of the SDV programs, there is a big rush to get software engineers working before we think about the infrastructure architecture. Interestingly, almost all the programs, the clarity on the architecture actually means there is a piece of paper on which something is drawn. Okay, and most of the hardware is not ready. Most of the constraints are not defined. Most of the understanding about the constraint doesn't exist. And then you get software engineering to work. Unfortunately, software engineering never fails in software engineering. It never fails in functionality. And of course, we can debate about good software engineer and a bad software engineer. Is a bad software engineer who doesn't think about the corner cases. He doesn't think about the negative test cases in his software. But most of the software engineers, good software engineers would think about functionality. They would prove that the functionality works. Most of the management knows that somehow they show that the functionality works. They also show that the negative test cases work. That means where the software is supposed to fail is anticipated and something is done about it. But I don't think there is any focus in terms of what to do on the system challenges. And now you have two things that are there in the top. That is the network authority. Ultimately, who defines the system? Is he in touch with the software guys, hardware guys, SOC guys, networking guys, and taking the right call? A very important, either a person or a committee to actually make this happen. Ideally, a person to do that. And do you have subsequently a testing model to do that testing? The second one is the platform. Have you identified the integration of software, mostly the middleware and the lower part? And have you fundamentally addressed all the issues of startup, load, contentions, bus loading, bus prioritizations, etc.? Have you tested that? Once you do this, then you have an environment on which the software development can integrate, and then we can start building up scenarios where their software could be tested for situations that actually fail in the validation, fail in the integration activities. And that is how you shift the problem on the right-hand side, which is the traditional validation, to the left-hand side, which is mostly what is the left shift of the validation. So I think as an industry, we need to appreciate that every choice that we are making is going to create some challenges. So from a go-to perspective, I wouldn't read through all of them. It looks like my time is already up. So just go through this. But I think as an industry, a lot of focus need to happen on what choices we make and hence which constraints do we expose, and then what are our answers to those constraints by doing the early integration and validation. Thank you.